let's shade the regions that is represented by the following set operations. What is our operation? A and B and C. That means this part is both in A, B, and C. So which region? Here. So this small area in both A, because A is the big circle here, so this part is in A, also this part is in B, and also this shaded area is in C. So the red part is the intersection of A, B, and C. Next example, A or B. Okay, what is A or B? That means or means everything of the A and A, B. So I'm going to shade A. I'm going to shade B. So A or B is the shaded area. Okay. How about next part? A and B prime. Okay, what is the A? So let's shade our A. How about the B prime? B prime is the area outside of the B or inside of the universal sets, but not in B. Okay, what is the area? That is the B prime. So I'm going to shade this area. Let's use this one. So not B. I know that if I'm shading the B, this is B. Not B is here. Still thinking this is better. So not B. Is area. Oh, not B. So shade all of the area but B. It's so difficult. So from next question, I'm going to make it simple. All right, I shade B prime. I shade the B prime. And what is the A and B? So that is the overlapped area or the intersection between the A and B prime. So which part I shaded twice? This part I shaded twice. That means if I clear this messy, I'm going to have, so if I clear this messy, I'm going to have the shaded area is here. Overlapped area. Okay, how about next example? C and B. So and is the overlap. So if I'm shading C, so just use stripes. This is C and B. Use different color to color B. This is B. Which area I shaded twice because this means the overlapped area. Okay, that is the red part. This is the A and B. Okay, just erase the rest of the part. Okay, next example. A or B in the parentheses and C prime. Let's do the parentheses first. A union B, that means everything, A and B. A union B. And how about the and C prime? What is a C prime? Let's use green to highlight the C prime. Okay, C prime. So all of the area except the C. So everything in the universal set, but not C. So between the two sets, we're having and. So what is the overlapped area? Okay, we can use blue. So the area I shaded twice. So it is here. You see, it's here. Okay, I'm going to erase rest of the parts. Okay, so this is the area representing this operations. Okay, C and parentheses A union B prime. Okay, so what is the C? We can use blue to shade the C. And so and the area A union B. So in the parentheses. So in the parentheses, we're having A union B. So A union B means A union B or A or B. But we're not looking for the A union B or A or B. We're looking for the prime. So we're going to highlight the area which is not the red part. Let's just use some stripes. Not A union B or A or B. Okay, let's erase the red part. Okay, what is the intersection or what is the overlapped area between the green and blue? That's the area here. So let's use red to highlight the overlapped area. Is the section here. Okay, we're only looking for the red area, so we can erase rest of the parts. Okay, erase the blue and green. Okay, these two sets, they have no intercept. They are independent from each other. So music blasting from cars, music we want to hear. Sometimes that happens. Counting formula for the union of two sets. So if I have a set A is the area here. It has the elements X and Y. And the set B is the area here, including the element Y and Z. For example, we are having X element. X represents a number of the elements. We have X elements here. We have Y elements in the intersection, or we say A and B. And we have Z elements in rest part of the B. Okay, so if I'm looking for A, the cardinality, how many elements of A union B? A union B is the shaded area. That is that's a Y, X plus Y plus Z. Let's erase it. X plus Y plus Z. And how about X, Y, Z? They are not given. They gave us the cardinality of A, B, and the cardinality of A and B. So A plus Y, X plus Y represent cardinality of A. Z plus Y represent cardinality of B. So how about the cardinality of A plus cardinality of B? And we add the Y part twice. That means I need to minus cardinality of A and B. So we got a new formula. So if I'm looking for the cardinality of A union B, that equals n of A plus n of B minus the intersection, the area I added twice, because I add the x and y and the y and z. So I add the y twice. So I need to minus y. That is the intersection of A and B. So we got a formula. A cardinality of A union B equals n of A plus n of B minus n of A and B. For example, if n of A is 10, n of B is 19. N of A and B equals 5. So the formula I learned is n of A union B equals n of A plus n of B minus n of A and B. I'm looking for n of A union B or n of A or B. We're having 10. We're having 10 plus 19 minus 5 is equals 29 minus 5, 24. Next example, if A union B, n of A union B equals 27, n of A is 12, n of B is 23, what is n of A and B? We have the formula, n of A union B equals n of A plus n of B minus n of A and B. So we have 27 equals 12 plus 23 minus n of A and B. Now we are looking for n of A and B. Then we can isolate the n of A and B. We can move this part to another side by switching the line. So here is minus, we're having positive n of A and B equals, switch the 27 to another side, becomes negative 27. 12 plus 27 minus, 23 minus 27. It is 35 minus 27 is 8. So n of A and B equals 8.